Topic 7 is about slope-intercept form. This is something that may be familiar to some of you when we start getting into it, either from your class last year, or maybe you have a tutor or somebody that's already showed it to you. It's a fairly common concept in math, and you probably have already been using it, you just didn't realize it. We're going to slowly discover it, though, through these notes, starting with number 1. Joni is doing some online shopping. She's purchasing shirts from a website that charges $12 per shirt and charges a one-time shipping fee of $4. Okay, most of y'all can already tell that that equation would be y equals 12x plus 4, right? 12x because it's 12 per shirt, we'd multiply, and then it's a one-time shipping fee of $4. We just add that on. So now let's make a table and a graph as well. If she bought 0 shirts, but still paid shipping, she'd pay $4, right? That'd be kind of silly, but let's pretend, right? She still wants the box or something. If she bought 1 shirt, that would be $12 plus the 4 shipping would be $16 altogether. If she bought 2 shirts, that'd be $24 plus the extra 4 would be $28. Most of y'all can see this pattern and continue it down the table. So now let's put these on our graph. Remember, the beauty of a video is if I start going too fast, you can always pause, see if you can get caught up. You can rewind to watch something again, etc. Okay, even though this should probably be a discrete graph because you can only buy whole number t-shirts, I'm still going to go ahead and connect them just for the purposes of the notes. So the goal here is to see what connections we can make between the 3 forms. So last lesson, topic 6, was about x and y intercepts. Let's start there. I notice in the table that I have a y-intercept of 0, 4. Well, I see that also on my graph over here at 4. Notice that in my equation, I also have a 4. That is no coincidence. That is my y-intercept, okay? Think about the y-intercept is always 0 and then a number, right? Well, if I plug that 0 in for x, it makes sense that I would have a 4 left over, right? Okay, what else have we learned about? We have learned about slope, right? So let's look at our slope from our table. This is increasing by 12, by 1. So 12 over 1 is really just 12. So my slope is 12 here. I noticed that over here in my graph, it's also 12. 4, 8, 12 over 1. Rise and run would be a slope of, again, 12. Well, look back at my equation. There's the 12. That is also not a coincidence, okay? What we have just seen is that that equation is written in slope-intercept form, which it's called that because it has a slope and it has the y-intercept, okay? It always looks like y equals mx plus b, where m is the slope and b is the y-intercept. That is slope-intercept form, okay? So let's just practice a little bit. The instructions for the next part say write the equation or the function rule that describes each line in slope-intercept form. So number 2 says that slope is 1/3, and the y-intercept is 0, 6. So if I'm trying to go for mx plus b, the m they just said is 1/3, the b they just said is 6. So y equals 1/3 x plus 6. It's that simple. Okay. 3, again, my goal is y equals mx plus b. They say the m is 1, the b is 0. So y equals 1x plus 0. Now, I will say on this one, we don't really need the plus 0, and we also don't really need the 1. So really, it's just y equals x, which should look familiar because that's actually the linear parent function. Number 4, same thing. Goal is y equals mx plus b, so I plug in the pieces. M is 0, b is -5, so y equals 0x minus 5. Well, 0x isn't really anything. So it's really just y equals -5. Well, what do we know about a slope of 0? That means it's a HOI, right? It's a horizontal line. Well, that's what this y and HOI is supposed to remind you of. That HOI, horizontal equations, are just written as y equals and then the number. There's no there's no slope that you have to deal with because the slope is just 0. Okay? Let's keep trucking. Which equation describes a line that has a slope of 1/4 and a y-intercept of 2? So that means my m is 1/4 and my b is 2. We'll look at A. A says y equals 1/4 minus 2. Well, we don't want minus 2, we want plus 2. So that's out. B. M is 1/4, B is 2. We're good. I like B. C. Most of y'all look at this and you see the 1/4 and you see the 2. However, we know that when there's parentheses, you have to multiply, you have to distribute, right? So really this equation says y equals 1/4 x plus a half, which is not what we want. D, again, cool, 1/4 and 2, except for this x has moved. Really, this one I could rewrite as 2x plus a fourth, and that further shows that the slope here is actually 2. The slope is with the x every time. No matter what order it's written in, the slope is with the x, so this one won't work either. So B was our only answer there. Okay, so now what do you do if an equation is given to you like number 6? This one does not look like y equals mx plus b, because in fact it doesn't say y equals at all, right? So we need to move some things around here until we've got the y by itself so that we can see the slope and the y-intercept. This is why we teach you literal equations in Unit 1. So I'm going to add 3x to both sides. So I've got negative y equals 11 plus 3x, but I could also rewrite it as 3x plus 11. That puts it in a better order. Then I need to multiply the whole thing by negative 1. So the y is truly by itself. And I get y equals negative 3x minus 11. Now I can see that that slope is negative 3 and the y-intercept is negative 11. Okay? So number 7, same thing. This does not say y equals mx plus b. That's my goal, right? So I'm going to try to get this y by itself. I'm going to start by adding 10x to both sides. I'm going to write the 10x first just because it's a little bit prettier in my opinion. I'm going to divide by 5. Now typically at this point, I would tell you to stop, right? Back in literal equations, it was okay if you just stopped here. However, we don't want to stop there because that doesn't tell us what the slope and the y-intercept are. We actually need to divide out this 5. It's kind of like distribution, but division, okay? So we're dividing that bodyguard out. So 10 divided by 5 is 2x. 20 divided by 5 is 4, and it's positive. So there is my slope and my y-intercept. Slope would be 2, y-intercept would be 0, 4. Last but not least, we have some distribution we have to do here. We need to add the 7 over. So I'm going to distribute first. Remember, 2 times the 6 is 12, divided by 3 is 4. I'm going to add my 7. And there's my slope-intercept form. So my slope is 2/3, y-intercept is 3. Okay? Back of the notes, you'll notice we've been given graphs. The instructions are, though, to write an equation for the graph shown below. So on number 9, I'm actually going to start underneath it with the slope and the y-intercept. So they've given me 2 perfect points here. Starting at A, I'm going to count my rise and then count my run. So 1, 2, 3, 4, 5, 6, run, 1, 2. So my slope would be 6 over 2 or 3. Y-intercept I actually can't see here, so we would have to keep counting it out according to my slope of 3, right? I'd be going up 1, 2, 3 over 1, up 1, 2, 3 over 1, right? And there's actually an easier way to do this that we will learn later, but for now, just trust me that it would end at 9, okay? So if I was to make that into an equation, I would have y equals 3x plus 9. So let's do the same thing here on number 10. Again, I need to start with my slope, so I'm going to find 2 perfect points. I'm going to rise 1, 2, 3, 4, and run 1, 2 in the negative direction. So my rise would be 4 over negative 2. Negative 2 is my slope. Y-intercept's right there at 4. So equation would be y equals negative 2x plus 4. Okay, last one. We have a horizontal line here, ahoy. So that means my slope is 0. My y-intercept here is negative 3. So this y reminds me that my equation is just going to be y equals, and then whatever the y does equal all the way across the line, which is negative 3. Okay? All right, so now they're wanting us to do the opposite. They're wanting us to create a line given certain characteristics. So on number 12, they've given us a slope of negative 2/3 and a y-intercept of 0, 2. Well, I need to always start at the y-intercept, start at the point that they've given me. So I'm starting at 0, 2. Then my slope of negative 2/3, that means the rise is 2 and the run is 3, except something has to be negative. So let's first rise 2 and run in the negative direction 3. 1, 2, 3. There'd be my next point. Let's keep that going. rise 2, run 1, 2, 3, etc. However, I can kind of already tell where the rest of these points are going to be. They're going to be somewhere over in this region, right? So that means I could also go down 2 and then positive right to 3. Again, down 2, right 3, down 2, right 3. So there is my line that has the correct y-intercept and the correct slope. So again, on number 13, here's my slope of 4. Here's my y-intercept of negative 3. So I go start with the negative 3. Slope is 4, which remember is really just 4 over 1. So I'm going to rise 1, 2, 3, 4, run 1. Rise 1, 2, 3, 4, run 1. Over and over. I could also go down 4 into the left 1. Try to anticipate what the point would have been before. Then I connect these with a line. Okay. Last one, I need to do the same thing, except I have a problem. This does not look like y equals mx plus b. So I need to move things around again until I see my slope and my y-intercept appear. So I need to add 1/2 x to both sides. So I've got y equals 1/2 x minus 8. Nice and easy. That was a quick one to solve. So now I've got the y by itself. So there's my slope. There's my y-intercept. Rise 1, run 2. Again, remember, you can pause at any time if this is too fast. And there's my line. Alrighty. Almost done. Now we're just going to move into tables. So number 15. Write an equation match the following. Again, we need the slope and we need the y-intercept. Well, the easiest part would be the y-intercept, the b, because it's always just the 0, right? 0, 12. Easy to find. The slope, though, is where you have to do your little loop-de-loops, right? So 12 to 6 is minus 6. 0 to 1 is plus 1. I could keep comparing if I wanted to, but I'm pretty sure that's the slope, so I've got negative 6 over 1. So my equation would be y equals negative 6x plus 12. Okay, next one, same thing. I don't see the 0 that I need for my y-intercept, so I'm going to hold off on that and go ahead and just find my slope. So 4 to 12 is plus 8. 1 to 3 is plus 2. So my slope would be 8 over 2, or just 4. But now if I keep that in mind, if my slope is just 4, or in other words 4 over 1, right, then I can actually just make this table go backwards, right? If I go back 1, I'll be at 0, and go back 4, I'll also be at 0. So actually my y-intercept here is 0, 0. It actually goes through the origin. So my equation would be y equals 4x plus 0, or really just y equals 4x. Okay, last one here is the points. Again, I need a slope and I need the y-intercept. Well, the y-intercept is just the point that has the 4. I mean, it has the 0, sorry, 0, 4. But then the slope, I have to use my slope formula, right? So this is x1, y1, x2, y2. So I'm going to do 16 minus 4 over 6 minus 0. And I get 12 over 6, in other words, 2. Then my equation is just y equals 2x plus 4. Okay? So, slope-intercept form, y equals mx plus b, is a very important equation form for you to know. We're going to be using it probably all year. It's one of the basics of algebra. It's very important for you to know and memorize and understand. Okay, so please let your teacher know if you have any questions. We'd be more than happy to help you, give you some practice problems, and work on this some more.